I'll try to make an uncut video regarding the build that I put on GitHub. This is the 3D printed handpiece with the adjust knob in the back to regulate the travel distance of the plunger. I will use the same controller that it's on the code. This is not a strong handpiece by any means. I believe that if we had a 2035 solenoid, it will be stronger. I have another handpiece that I will show you also. These lines here are 5 millimeters apart from each other, and this one are 1 millimeter apart from each other. In the beginning, I just had some for reference. I'm using here a 120 degrees graver. I will test both handpieces. I will tell you the frequency that I'm using. So for the beginning, I will have a 10 hertz or 10 pulses per second on the handpiece, and using also the analog foot pedal to control it. So I can just slightly press, and then you can hear like a pigeon starting to knock. This might be good to control what you want. You can also set a higher power or lower power if you're doing more delicate jobs. So I'm just reducing the power to the coil right now, and then I'm increasing in the potentiometer. And now I'm just going to control it on the foot pedal. Okay, let's try to have some tests here. I will try to go as deep as possible in the 10 hertz. Maybe 5 millimeters will be enough just to see what's happening. I just sharpened the graver, so it might be okay with the Adenta Seragloss, the yellow one that it's here. So let's see. Yeah, it's a small cut, not that deep. Let's try to increase the frequency to around 25 hertz. Now it's a bit stronger, and I also have to put a little bit less travel, a little less travel, because otherwise the frequency won't match. So you can hear right now that the plunger is not moving according to the frequencies. It's kind of escaping of the magnetic field. So I have to deepen. Yeah, now it's a bit better. Let's try again the same 5 millimeters. Yeah, went a bit faster and a bit deeper. I'll try to go all the way to the maximum power, 50 hertz, and see if it can follow. I believe it's going to be weaker than the 30 because you have to reduce so much the travel that it doesn't leave energy or space to hit it. Yeah, let's see. Maximum power, 50 hertz. Same result. Now I'm going to show you a custom handpiece that is I try to make from another solenoid here. And right now I have a plastic handpiece, and I believe that the plastic is not the best solution. Just like I mentioned in the readme file, I will have it transferred to a metal construct to see what will happen. And this is way more powerful than the other handpiece. Let's put it here. Try again the same 10 Hertz. I will use the same graver, just removed from. And then you will be able to see how stronger the plunger is because of the weight and the coil of it. So 5 millimeters again. I'll try to make the same side here. It's going a little bit deeper. Maybe I went too deep. Yeah, it went way deeper than the other one. Let's try the 20 Hertz. 25 actually, it's the same that I tested before. Same power. Sorry about the ears of the people that are listening with headphones. Try to do it side by side, a little bit deeper. Yes, we went way deeper. And the 50 Hertz. Again, 50 Hertz. Let's try to. We'll try to take this to the limit. This is not a. This is a carbide graver that I'm using from a known brand, and it's just a generic carbide graver, so they tend to just chip because of the tenacity of the alloy. So since these two lines are 1 millimeter apart, I will try to use the 120 degrees graver and take everything all at once. It's not recommended when, according to what I learned, to do it all at once. But I will try to do it just to see what this is capable of in the 50 Hertz. Okay. 1 millimeter. Let's go. Yep, 1 millimeter. You can see some shakes here. Maybe it's the controller, the technique of holding the ball. Now it's a bit sharpened. Just for fun, maybe let's try to use another graver. If I can, I have here. I will try to replace the one I was supposed to just do it beforehand. But I will try to put a 2 millimeter wide graver in the handpiece, a flat one, and let's see what it's capable of. Let me measure just to see if I'm being truthful to what I said. No, it's a 1.4 millimeter. This is 1.4 millimeter. Let's see what I can do with it. I will just go half centimeter here, 5 millimeters. Yep, went all the way. and it's a little deep. Maybe uh, I I can't gauge just by looking at it, but it's really deep. I will put some pictures in the page so you wouldn't understand how deep it is. Maybe you can also change the frequency or use different tools. If you're going to inlay something, you can change the texture in the background. And just for the information, here is a generic brass alloy. It's not bronze. I believe this is too hard for what actually represents a jewelry, maybe silver or gold. Gold, of course not. But this is too hard. I tried to cut it, and it was so stressful that I just gave up and bought some best better brands for testing gravers for jewelry. I will show other modes. Right now I'm doing just the potentiometer mode, and this is the handpiece according to the explanation of the code. So I controlled everything, all the pulses from the foot pedal right now, so I can just increase the power. I will change the mode for pulses, and in pulses you can choose 1 pulse per second. You can increase to as many as you would like to. And then I have the direct one. I'm going to change this one in the next code. This just gives full power just in the touch of the foot pedal. Maybe this can be useful for someone who's stone setting on bezel setting. And that's it. I hope it's useful for someone, and thank you so much for your time.